All right, we're going to do a quick overview of the properties of hydrocarbons. Remember, the hydrocarbons are simply C and H. There's nothing else to them. Because hydrocarbons are just C and H, they are highly nonpolar. They're highly nonpolar. So because they're nonpolar, what that means is that they generally have low solubility in polar solvents like water, but they do have high solubility in nonpolar solvents like hexane, which is essentially just C and H solvents. Um, because they're nonpolar, we know their main intermolecular force is pretty weak. It's the London dispersion force. And so, as a result of only having London dispersion forces, they have pretty low boiling points and melting points compared to other polar molecules. But in general, we do see this trend over here, as you already know. If you look at methane, butane, hexane, octane, these are all alkanes. As the number of carbons increases, you get higher boiling points. And that's because you have more LDF, which leads to higher boiling points because it's harder to separate the molecules and needs more energy, simply due to more LDF. The last thing you should realize about hydrocarbons is that they also have certain chemical properties. In general, alkenes and alkynes are more reactive than the alkanes, and that's because it's a little bit easier to break parts of the double bond and parts of the triple bond compared to just the single bond. So if you think about it, a single bond, yes, it's only one line. So you think, oh, shouldn't you break that more easily? Well, okay, yes, that makes sense, that logic, but don't forget the double bond is two lines. Okay. Um, and so you have a strong line, and then the other line, you can break that. So it's more reactive. So in that sense, the double bond is more reactive than the single bond, even though overall the double bond is stronger because there's two kind of hooks connecting the atoms. One of the parts is a bit weaker that you could break to do some reactions, and the other part just doesn't really break. And so that other part that doesn't really break, that's what the single bond essentially is. That's a bit of a simplified way of looking at it. But main idea is that double bonds and triple bonds are more reactive. We'll see that in more detail when we get to the organic reactions portion of this unit. So for now, you should know how to explain the physical properties of hydrocarbons, how to rank hydrocarbons based on their size, what forces are present in them, and why they may dissolve or may not dissolve in water or hexane.